Interstellar is doubtlessly one of the greatest science fiction movies of all time. Nolan brothers have definitely proven themselves to be geniuses by writing this story based on such scientific facts, facts that are not easy to understand for well-educated people, and yet the story is appealing to everybody. In this video I try to explain some of these facts to make sure you know what you need to know before or even after you watch the movie. And once again, what follows is scientific facts, not just some made-up rules to base a movie on, as some science fictions are. Let's get started with the theory of relativity. General theory of relativity was published by Albert Einstein in 1915. This theory proposes the existence of black holes as an end state of big stars, where space-time is distorted in a way that not even light can escape gravity. This theory also implies time dilation, which means time runs more slowly for the observer under the effect of the greater gravitation. For example, an astronaut traveling across the gravitational field of a black hole may observe 1 hour passing on his watch, while during the same period, people on Earth have experienced years gone by. This is exactly what happens at Laura Miller's planet. They get to spend a little more than 3 hours on the Miller's planet, but 23 years have passed for the people on Earth. And again, in the end of the movie, when Cooper spends a few hours in the middle of the black hole, not long enough for his oxygen to run out, decades have passed to the people on Earth, long enough for them to build their spacecraft, travel to Gargantua, and find Cooper on the way to their new home. Singularity. A singularity, or gravitational singularity, is a location in space-time where the gravitational field of a celestial body is infinite, as well as the density of the matter, say, for example, the heart of a black hole. At such a location, the laws of nature as we know in a three-dimensional world are not effective. This could be a five-dimensional world where, according to the movie, gravity and time can be physical dimensions. Information in a singularity is not available to mankind. Data from the singularity in the heart of Gargantua, the black hole in the movie, can be of use to Dr. Brandt, the father, but no one can access this quantum data unless they go into the black hole. Spacetime. Spacetime is an entity present in every spot of the universe. What exactly it is yet unknown to mankind, though Einstein's theory defines it to be of a geometrical nature. Imagine a very large network in the universe. If you place a large mass on this network, the shape of this network is distorted. Let's say it is curved in a way to make room for the big mass. The bigger the mass, the bigger the curve. Since some room has opened up in the curved net, other masses nearby will move towards the center of the curve and eventually will get closer to the first big mass. So we can say the mass of objects shapes space-time, and the shape of space-time decides where objects should be. This is what causes gravity. Event horizon. An event horizon is a border around a black hole, out of which no entity can escape, not even light. Anything, including light, that passes this border is caught in the gravitational field of the black hole forever. Images of black holes usually demonstrate a black circle around which light and particles are orbiting into the black hole. That black circle is not the mass of the black hole. In fact, the border of that black circle is the event horizon, and far in the center is located the mass of a black hole. But how's that related to the movie? The point is that physics rules, as we know them, the rules of a three-dimensional world, do not apply in a black hole. Especially, time and gravity might have totally different behaviors from what we know. But how can we know the rules of a black hole when no signal or message can escape it? This is exactly the information that Dr. Brand needs to complete his equation. So, Cook gets into the black hole, to the heart of the singularity, with TARS who can gather the quantum data. needed to complete Dr. Brand's equation. Then he finds every moment of his daughter's life presented simultaneously at the core of the black hole. And this is how time is defined in a singularity, all at once. Of course, there is no scientific ground for this, but to make the communication possible, another major entity of our universe is used by Cooper, that is gravity, which is manipulated by Cooper to move the watch hands in a way that signals a message in Morse code to his daughter. After all the science of the movie, there is one element that brings it all together, without which mankind would have been lost, and that is love. The purest love of a father and daughter was the medium to carry the burden of all humankind and save all. Murphy's Law. There are theories that relate this law to Edward Murphy, who, after failing a test, said about his assistant, "If that guy has any way of making a mistake, he will." Then the epigram underwent a few changes, like, "Anything that can go wrong will go wrong. Anything that can happen will happen." All of which carry a negative meaning. That is, if there is the minimum possibility for something to go wrong, that will eventually go wrong. But Cooper has a different notion about Murphy's Law. He thinks of the law in an optimistic way. Whatever can happen will happen. So if there is the slightest possibility for something to happen, something that can be good or of choice, Murphy can make it happen. In the course of the story, we can see she has a great part in making the impossible possible. She will be the one to save humanity. And that's exactly how Cooper thinks Murphy's Law works. If it is possible, she will do it. Wormhole. While approaching the wormhole, Ramley gives a very clear explanation of what a wormhole is. What he demonstrates on a piece of paper is this image. If spacetime is an entity present in the whole universe, we'll be able to make a shortcut between 2 points in the universe by distorting the shape of the spacetime. Traveling through a wormhole can save millions of years for the traveler. Of course, human beings don't have that much time. Lazarus. Lazarus alludes to Lazarus of Bethany, a biblical character. He was a follower of Jesus and was brought back to life 4 days after his death. Any reference to his name in cinema, literature, or even science symbolizes resurrection. Even when something is still alive, but is destined to die, but is saved eventually, the name Lazarus can have its usual function. The name Lazarus is heard in the movie twice. The first time is when Dr. Brand, the father, is informing Cooper about the missions in which probes have been sent to another galaxy to find a new home for mankind. The mankind who Dr. Brand knows is going to die soon. In this scene, there's a moment of contradiction between Cooper and Dr. Brand over the name Lazarus for the missions. Dr. Brand mentions that Lazarus came back from the dead. Well, he already knows that the people living on Earth are going to die and a new generation is going to live in the new world. But Cooper doesn't yet believe in an end for the human race on Earth. That's why he answers, "But he had to die in the first place." Cooper hopes to save the people on Earth, but Dr. Brand finds it impossible, though he doesn't reveal the truth yet. The second Lazarus is Dr. Mann. When they arrive at Dr. Mann's planet and over his hypersleep pod, the scene provides all the necessary elements. The coffin, the shroud, Cooper, who represents Jesus, how they stand around Mann in a more full way, the weeping, and finally Mann saying, "You have literally raised me from the dead." And Cooper says, "Lazarus." Hadn't they arrived, Mann would have been as good as dead, since he hadn't set a waking date on the hypersleep pod. Cooper represents a modern Jesus many times in the movie, brings back the dead, sacrifices himself to save humankind, and finally reappears to the world, or resurrects, as a young man. Do Not Go Gentle Into That Good Night. The poem by Dylan Thomas, Do Not Go Gentle Into That Good Night, is one of the most well-known pieces of poetry of our time. The poem is said to be written for his dying father. Therefore, it is used or referred to in many movies or other types of production. In situations when somebody is being encouraged to resist death and fight against it. In Interstellar, the poem is recited twice by Dr. Brand, the father. The first time is when the team has just embarked on their journey to the perilous, endless world of darkness. This recitation matches the three ongoing events in this scene. First, Dr. Brand knows that Plan A is not going to work and the people on Earth are going to die. Second, the crew of the spacecraft are going to start their hypersleep, or as they call it, the long nap, which is similar to death. And finally, the team is starting their journey into the endless outer space, the eternal night and darkness, with all the danger awaiting them and little hope for coming back home. The second recitation, again by Dr. Brand, is done when he's at his deathbed. Of course, he doesn't get to finish the poem and he dies. But though he was one of the first to know that life on Earth is ending, he didn't give up and fought. Though he died, it didn't go easy. Okay, so we learned all the facts. That's it. Don't forget to like this video and subscribe, because more videos will be uploaded soon. Don't forget to comment your ideas about this video and the topics. Thanks for watching.